this video, we're going to explore what area is, and we're going to look at calculating the area of squares and rectangles. So you would have been doing this for many, many years, but we're just going to go over the rationale behind it and some examples. So if I asked you what is area, what would you say? Pause the video now and have a think about what you would say. So sometimes when I ask people what area is, I get this kind of answer. Area is the inside, or something about area being the space on the inside. So first of all, if you just say the inside, it's the inside of what? What are we talking about? The inside of a box? The inside of a fridge? Like, what are you talking about? And also, what quality is it that you're looking at when you talk about something on the inside? So again, just like with perimeter, we need more detail to fully explain what area is. And this is the definition. Area is the amount of two-dimensional space within the boundary of a shape or surface. Let's take this step by step. So, area is the amount of two-dimensional space. So again, we're talking about an amount, just like with perimeter, except this time, instead of it being something like centimeters, meters, kilometers, we're talking about two dimensions. So we're really going to be talking about centimeters squared, meters squared, kilometers squared. So this 2 is literally showing you the two dimensions. Now, what is a dimension? We talk about 3D when we go and see a 3D movie. We're talking about 2D now, which is meaning like flat shapes. But what does a dimension actually mean? And it can be a bit hard to describe, but what it means is it's a description of moving through space. So when we're talking about two dimensions, we could talk about the first dimension as being moving right or left, and then the second dimension would be moving up or down. And if we went to third dimension, it would be like looking at a distance coming out of the screen or into the screen. So if we've got a rectangle, we talk about length and width. If we talk about a parallelogram, we talk about base and height. So it's just describing those two different dimensions that you could move in. So the amount of space moving in two dimensions within the boundary, take this shape for example, we're talking about amount of two-dimensional space within the boundary. So everything inside this shape. So we're talking about all of this pink stuff. Okay, so within the boundary of a shape or surface. So you could be talking about a shape, or you could be looking at the surface of a three-dimensional object. So we usually call that surface area. So we could work out the surface area of this box by working out first of all the area of this two-dimensional shape or two-dimensional surface, this one here, and the three that are hidden, and adding them all up, and we would have the total surface area. So it can be something that's three-dimensional, but we're only talking about each particular surface one at a time, and then if we're talking about the total, it's called total surface area. So area is the amount of two-dimensional space within the boundary of a shape or surface. When do we use area? So again, anytime that you're planning to create a house or maybe renovate a house and change the carpet, change the tiles, you need to know areas of different parts of this house. So you need to know what's the area of tiles that you're going to need for this house. What is the area on this floor in here of these floorboards that you want to put in? And of course they'd be under the bed as well. You would need to know this area all in here for the carpet. Remember, perimeter was working out these skirting boards around the edge here, but area is everything, this two-dimensional surface in here. And again, you can see this kitchen, it's got tiles, it's got benches, so you need to order bench tops of a certain area. And then if you're doing any sort of painting, you need to know the area of the whatever it is that you are painting. And when you get a tin of paint, it actually says on it how much area it covers. And another one, if you're a bit crafty, if you make clothes, you need to lay out patterns, and they're going to take up a particular amount of area that you're going to need to cut out. So you need to make sure you've ordered enough area for your particular piece of material so that you can fit all of your pattern pieces on. Okay, having a look at this rectangle here, each of these little squares is 1 centimeter squared. So we could go through and count them. And we can see here 24 full squares. So our area is 24. We're in centimetres, but we're in centimetres squared. Remember, now we're going in two directions. We're going in this direction and we're going in this direction here. And we're looking at everything within the boundary. So you can do it like that, but it gets a little bit boring counting squares and it kind of becomes limiting. So instead, see how we've got a side length here of 6 and a side length here of 4, and I should put these in centimetres. And we can just do 6 times 4 to get straight to that result of 24 centimetres squared. You've done this heaps, and it's called area equals length times width, and you can write it as A equals L times W or just A equals LW. And we call this a formula. Anytime we have a set of letters or pronumerals that represents something that we're going to do mathematically and we can use it over and over, we call it a formula. So the formula for a rectangle. Have a look at this one here. We've got a rectangle that is 4 centimetres across and 2.5 centimetres down or up and down in that second dimension. And if we went through and counted the squares, we would get 8 full squares there, and then we've got not a full square because this square would look like that. But we've got half of one here and half of one here, so that would be your 9th square, and then these two would make up your 10th square. So now that we've got this formula of area equals length times width, we can do 4 times 2.5. And this gets us straight to 10, meaning we can straight away say our area is 10 centimetres squared, 2 dimensions, without having to count up the squares. So here are 3 examples. If you feel confident, you can just fast forward the video and check that you're on track, but otherwise stick with me. So make sure you're checking all your units, meters, all good to go. So area equals length times width, which is 73.7 times 58.5. Put it into your calculator and you get this answer. So make sure that you've put your units on and you've put the squared in showing those 2 dimensions. When we get to this example, we've got millimetres here and centimetres here. So it's up to you which one you're going to change, but I'm going to change this one from centimetres to millimetres, and I know that I can just jump that decimal point over 1, so I've got 98.7 millimetres. So again, we've got our formula, length times width. Make sure you put the A out the front. We substitute in all of the correct numbers, getting our final answer of 1500.24 millimetres squared. Now we could have done this in centimetres, so we could also get 15.0024 centimetres squared. So if you did that different conversion, then that's your alternative answer. Okay, over here we've got centimetres and we've got millimetres. So I'm just going to go like this, and I'm going to change that to a C. So now it's all in centimetres. So area being length times width, which is 20 times 29. So our final area here is 580 centimetres squared, 2 dimensions. Okay, those are 3 examples for you. What I'm going to get you to do now is have a go at these 3 yourself. So pause the video, copy this out into your book, have a go, and then resume the video to check you're working out. So how did you go? Check your answers now to make sure that you put in all of your units, meters squared, and centimeters squared. Make sure you did all of those conversions. If there's anything that you haven't put into your working out, can you please add it now? So if you haven't written area equals length times width at the top, go back and put that in now. It's just an excellent habit to get into. And thanks for watching.